Joining me on this panel are Scott Amyx, Managing Partner of Astor Perkins, Dr. Dave Coleman, CEO of PickNik Robotics, Jordan Kretchmer, CEO of Rapid Robotics, and Dr. Wesley Zheng, CEO of Posh Robotics.
I'll just give everybody an opportunity to give an overview about your company. We'll start with PickNik Robotics.
Yeah, so at PickNik, we've been in the robotics manipulation industry for the past couple of years, or really the past 8 years. And we serve a lot of different companies in enabling better use of manipulation. And so we've recently rebranded ourselves as the unstructured robotics company, meaning the problem of not just really what you see in a factory of like everything's exactly where you expected and the robot's operating blind, but to really enable the next level of capabilities, we need robots that are dynamically planning and understanding the scene it's in, the environment, and being able to auto configure itself and like have a higher level of intelligence. So some examples of applications that we're actively working in, we've done a lot of ag tech projects of picking strawberries, tomatoes, outdoor environments, other types of produce. And it requires a higher level of understanding from the robotics, from the robot arms, to the manipulators. We've done a lot of work on ROVs underwater for oil and gas. We're starting to see a little bit of progress in the home space, still a little bit of forward thinking, but also it's great to hear from Luke at ClearSpace. Companies like his we're collaborating with in even the space industry on manipulating for setting up new habitats on the lunar surface or servicing satellites. And so, our thesis basically is that it's been way too hard to use these robotic arms, and we've kind of been hindered by that. And so we're bringing out a product to market that is making programming intelligent robot arms cheaper, faster, and easier. And so we've already working a ton of top brands in the past, and we have this open source product, Move It, that's widely popular. And yeah, our vision is that anyone can now use a robot arm, whether it's manufacturing or any small business or any industry. And so that product is called Move It Studio. It's available for download now on our website. And just a few quick screenshots about what it looks like. It's a low code environment for configuring the advanced algorithms that you typically require tons of R&D, like millions of dollars, many months. We can now do in days, and you can reconfigure robots on the fly. And it gives you lots of different ways of understanding the environment, seeing what the robot's thinking, and programming the arm. So that's just what I wanted to cover from a few quick slides, and I'll pass it on.
Great. Thank you, Dave. Let's go on to Jordan to talk about Rapid Robotics.
Hey, everybody. Dave, I didn't realize you were doing slides, man. You're making me look bad. But I'll give a brief on Rapid. So we started Rapid Robotics almost 4 years ago to solve the labor shortage crisis in the manufacturing sector. We deliver robotic work cells that are pre-trained using computer vision and AI, trained using the CAD files of the work cell environment, as well as the parts that we're going to be manipulating, to execute almost every common manufacturing task, like pad printing, injection mold removal, ultrasonic welding, palletizing, packaging boxes, that sort of stuff, all with no programming required and no systems integrator. And then we manage those fleets of robots on behalf of our customers 24/7, 365. So they don't have to have any in-house expertise to manage these. We deploy the arms in as little as 3 weeks versus the 9 to 12 months that's typically required via a systems integrator. And our payment model is a RaaS, Robotics as a Service model, that costs on a monthly basis about 50 to 75% less than the cost of a human operator on that same task. And we have deployed robots across almost every manufacturing sector, lots of automotive, medical devices, consumer packaged goods, plastics, metals, wine bottling, you name it. Our robots are producing it live out in the field today.
Okay, great. Thank you, Jordan, for that. And Wesley, Posh Robotics, please.
Wesley, I'm the founder and CEO of Posh. Posh is trying to optimize the disassembly, recycling, and reuse of end-of-life EV batteries. And as you're probably aware, there are a lot of EV going on the road. And at the same time, there are a lot more EV batteries get towards the end of life. And what we are trying to do at Posh is to figure out how to optimize the value of those batteries by figuring out a way to effectively or efficiently disassemble, test, and then reuse or recycle those batteries in the most optimal manner that can reduce the carbon footprint and can potentially extend the life of those batteries. We started a company just over a year ago, went through YC, raised a C round, and now we are building our first facility in Hayward, California, with a 10,000 square feet facility, and will be the first demo line probably in the country, try to automate the disassembly and testing of end-of-life EV batteries.
All right, great. Thank you for that, Wesley. Now, I know at a high level, I think most of us agree as to some of the business drivers for automation, but we really are interested in understanding, when you think about your prospects that eventually convert into customers, what are the definitive reasons why they're opting to employ your solutions? Again, this is open to all of you.
I'll go. Go ahead, Dave.
Sure. I was going to say, I think the robotics there's a lot of buzz around robotics right now, and people see that there's a clear ROI for automation, but the limits of what prior automation could do, the stuff that we've seen in the past few decades, it's kind of an old mindset of these factory industrial approaches. And so they work with us because they see us as a solution to the next level of innovation and automation and complexity. I think Jordan has a similar viewpoint. You want to go ahead?
Yeah. So, for us, it's all about deployment velocity. So the number one thing that we see in the market today is the labor shortage is going up exponentially. So the labor shortage, just in manufacturing, went up by 375,000 unfilled positions last year. And there were only about 28,000 robots that were deployed. And that's just in the US. And so as the labor shortage is going like this, and robotic deployments are basically flat to like literally about 3,000 to 5,000 more robotic deployments happen each successive year, while the labor shortage is going up by hundreds of thousands, that's the crisis that we're in. And I think that's driving, on the manufacturing side, companies of all sizes. We work with companies that are less than $50 million of revenue a year, and we work with companies over $10 billion of revenue a year. And the exact same problem exists. There aren't enough people in the world to program the robots necessary to be deployed to fill the labor shortage. And so for Rapid, I mean, that's the key aspect of the market that we're looking to go after. And that problem exists at every scale of facility. Mm-hmm.
Well, that's certainly that most of us have heard or see by reading articles, but at the same time, if you could get more granular in terms of what's really happening on the ground level in terms of adoption, and love to hear each of your perspective, recognizing that just because there's labor shortages doesn't mean that you're going to have immediate adoption by every sector, every types of firms.
Yeah, I mean, it's on the ground, the issues are the status quo, right? So you have organizations, a lot of these companies have existed for 75 plus years. And they've done things the exact same way in that period of time, right? You pick up the phone, you call a systems integrator, you say, hey, I need to automate this part of my facility, or I need new machinery over here. I don't have the skills in-house to execute this. Mm-hmm. And that's a swing that is well known across the company, right? So the CFO, the procurement team, the legal teams, the executive teams, the board, they all know how to buy like that. And so even though it's not very effective or efficient to buy that way anymore, because there are so many other options for automating, sort of transforming what we call bottoms up transformation, automating away the easy stuff as inexpensively as possible and working your way up versus starting with massive automation projects. That's a big culture shift within a lot of these organizations. And, I can't even count how many facilities we've walked into and they say, hey, here's our 5-year automation plan that we put in place 4 or 5 years ago. And we ask, well, how much of that have you accomplished? And the answer is almost none of it or none of it. And so, fighting the status quo is kind of the hardest part of our job, and educating the market that there are new ways to purchase and easier, slimmed down solutions that can solve these problems bottoms up.
Now, to that point, SIs are certainly channel partners and a critical one, but at the same time, where cases SI are helpful in accelerating sales velocity, And in what cases are you able to effectively disintermediate and just go direct?
I feel like I'm talking a lot, but I can start the answer to this. So systems integrators are great for big long-term projects. You have an evergreen system that you need deployed. For example, factory refreshes that are happening in the automotive sector right now. Sort of the factories of the future that are being developed in the automotive sector to handle EVs and more SKU changeover and more products and all of that kind of stuff. You see systems integrators adding a lot of value there, where it's a long-term project that the end result is going to be there for 20 or 30 years. That's what systems integrators are fantastic for. We're at Rapid, we try to fill in the gaps, right? So not doing massive automation projects, but dropping in a robotic arm work cell that knows how to load a piece of plastic into a pad printer, printing a serial number for a medical device, and then putting the into a box, right? The little stuff makes up about 80% of all manufacturing production. And that's where systems integrators actually don't really play, because they're small, little bite-sized projects, right? But at Rapid, we look at adding all of those small bite-sized projects up. And at the end of the day, you've got 80% of all manufacturing tasks that are spread across 100 or so different common kinds of operations.
Mm-hmm.
I have a different perspective, Scott, on the problem that Jordan is naming here of the need for lack of workers, a shortage of robotics talent, and what we see in a little bit slightly different industry focus is a lot of R&D groups, a lot of startups, so corporate R&D, government agencies, but also there's a ton of startups right now trying to bring robotics to the market for whatever application, and this is largely outside manufacturing, but they come to us asking for help because they underestimate how hard and how difficult some of these algorithmic pieces are. And so what we're trying to enable is this younger generation who's more comfortable with programming and software development, giving them tools to do that very quickly. So making it more like building an Android app for a phone or an iPhone app. And so really enabling, not getting past systems integrators, but like allowing any group who can program to also be able to program robotic arms. And robotic arms are a unique approach to the automation need because it's a lot more general. You can have them do a lot of different things, whereas traditionally a machine can be very optimized for one task, but then it's not good at changing over to different types of tasks, whether it's different sizes of product or it's a totally different thing. So we're working towards more general purpose robots that anyone can program. And I think that will also help in a different way solve some of the labor shortage problems by allowing everyone to solve it.
Mm-hmm. So let me go to Wesley, because you're coming more from a startup perspective, and it's a different use case, right? You're not a typical robotics company. You guys are primarily focused on EV, and robotics is a means to that. So talk to us about your approach.
Yeah, I feel like Rapid and PickNik, they are building the Swiss knife, and we are the one using the knife for a specific application. So we are focusing specifically on focusing on a specific problem in the industry, which is how to process EV batteries. And the interesting thing is that most of the battery manufacturing today are highly automated. A lot of the EV production is getting very well automated as well, but the reverse process is almost 100% manual today. And as we are building more and more gigafactories that are highly automated, we need more gigafactories to deal with the end-of-life batteries as well. And today we have no such gigafactories, at least in United States. And I foresee we will have to build similar facilities in the next 5-10 years in order to process the tens of millions of batteries that we are getting. So one estimate is there will be about 10 million tons of end-of-life EV batteries by end of 2030. And that's a lot of batteries. The one reason I started Posh was because I was visiting a company in Oklahoma. They were dealing with one of the major auto OEMs battery recall, and they hired about 1,000 technicians to disassemble EV batteries because there are about 140,000 EV packs that recently recalled. And to do that, they built a 1 million square feet facility. Again, there are about 1,000 people just turning wrenches, handling like high voltage system, which is super dangerous. And that got me thinking that, wow, that's something that really need to be done in a different way. And after a few other visits to different companies, I saw that it's kind of like a typical problem of core industry. That's how I got started with Posh, and I think there's a lot to be done, and I think a lot of the robotic system currently under development can potentially be used for the type of application that I'm looking at, but there are also some technical development that we need to work on, such as figuring out how to take harnesses, zip ties apart in the EV packs. Those are some of the technical challenges that we are still working on.
Well, the good news is I think you have the right panelists to talk about some of those things, but I just want to make sure your mic is kind of going in and out. But staying with you, Wesley, is that we are seeing that auto insurance companies are totaling EV cars like Tesla's, even when there's just a minor accident or small damage to the batteries, because of the fact that these batteries are kind of structurally integrated into the body itself. So just a lot difficult to get it out. I'm just curious to understand from your point of view, at what point in the process are you guys getting involved? Are you starting with, let's say, a damaged car, for instance, or has it already been removed and you're just dealing with the battery itself, for instance?
Yeah, today we work primarily with auto OEM. We have been working with Nissan. They have probably the most end-of-life EV batteries today because they've been around the longest. And we work with battery pack. They're already out of the car. So most of the auto OEMs or dealer, they will take those batteries when there's a replacement or when there's a warranty kind of recall or reposition. And usually a third party will take care of those batteries by either disassembling or recycling or reuse. So we take the batteries from the auto OEMs once they're out of the car, and we take care of everything else.
Gotcha. And going back to Dave and Jordan, some of the use cases that Wesley talked about in terms of zip ties and other things that he needs to do to disassemble and essentially reassemble the useful batteries, how would your solutions be able to help in that regard?
Yeah, wiring harnesses, zip ties, twist ties, those sort of things. We've had customers come to us, and we are working on better machine learning techniques to recognize, because they're unpredictable, the exact location they'll be in, especially if they were originally assembled by a human. And so that's the kind of flexibility that I was referring to earlier in terms of having a robot be able to dynamically come up with a unique plan for every individual set of little problems like that, and create a grasping scenario to unwind that zip tie or cut it or what have you. That is the sort of problem set that we are tackling. Very difficult manipulation problems.
Mm-hmm.
Yeah, I was going to say, those are things that require, if it requires a human to have two hands to execute the task, the level of dexterity required is typically not found in any sort of end-of-arm tooling option in the market right now. But, if we were to try to go do a task like, wire harnesses or, executing zip ties, cutting a zip tie, no problem. Putting a zip tie together that requires, dexterity, more of a problem. We would actually partner with somebody like PickNik, right, on the motion planning side of this. But my guess is that there's not anybody that's really gotten to that place yet, because the end of arm tooling is the actual problem, right? How do you create a dexterous enough gripper that is able to manipulate, string or loose materials in such a way and with high reliability and accuracy? And when you're dealing with EV batteries, obviously accuracy is insanely important. Our office is right across the street from Ample in San Francisco, and they just had a huge fire a couple of months ago and blew up their office right across the hall from us. And so working with, combustive materials, especially, you don't want to be doing things that are high risk. But I think we're getting there, right? With companies like PickNik and what Dave's team is doing, executing, really, really complex, motion planning and manipulation, algorithms. All we need is end of arm tooling to kind of get there. Where robotics are really valuable in batteries and sort of overall, semiconductors and electronics, is a lot of visual inspections. We do a lot of visual inspection of EV batteries and other electronic devices like PCB boards and things of that nature. But as of now, there's not great solutions for like really, really dexterous kind of task.
So my next question is really for all of you, which you're starting to allude to this notion of synergistic ecosystem is that no one company can necessarily solve all problems. So whether it's going to a potential prospect or trying to solve a particular use case really requires being able to pull in other partners with different capabilities to do the full solution. If you could talk about that, and Wesley, I'm certainly very interested in both what you're doing proprietary internally, but also capabilities that you're looking outside.
Yeah, we are very open with collaborating with other partners. For example, we are collaborating with one of the national labs on using teleoperated robot to start doing the disassembly first, and then we learn the process and train the robot to do it by itself. Because if I give you a batteries with all the zip ties and connectors, it's very difficult for a robot arm to begin with, like to start like disassembly in the first place. So basically, what we're trying to do is to how do we use teleoperated robot to learn the process and then train the robot to do it by itself. We're also collaborating with another company in Europe doing harnesses removal. They specialize in that space. So we are fortunate enough to have the same investor, and we are working on figuring out what's the best way to do it the most in the most efficient manner. So I think the problem is complex enough, and it's unlikely that a single company can solve all the problem, and collaboration is definitely the key here.
Yeah,
I'll add something. Go ahead, Jordan.
No, I was going to say to us, the ecosystem is everything. You rewind 5 to 6 years ago, there weren't a ton of robotics companies doing work in the cloud. And there weren't a ton of robotics companies that had robust APIs and SDKs. Now, almost every modern robotics company, especially ones that are software-based, and the robotic arm companies, UR and Yaskawa and others, give access at a level to their systems that were not provided before. And so the end result is like we can look at sort of the rising tides, rise all ships situation, where the more robust the ecosystem is with specific kind of technologies that are easy to integrate together, you get really robust solutions that are great for the market. A great example of this is AMRs and our robotic work cells, right? So currently, or previously, parts had to be shuttled from one end of the facility to the other by humans, like rolling carts around, or by adding conveyance from one end of the facility to another to get parts effectively through the environment. And with the advent of modern AMRs, right, that are cloud connected, we can actually connect to those systems and see where those AMRs are. So parts can be delivered to our robotic arm work cell, and we're integrated to that AMR system. So when that AMR arrives, we get the signal. We use our cameras to detect exactly where the AMR is that's holding all the parts, and the robot can get to work. And so that kind of modernization or flexibility or modularity is now accessible and available in the market, right? To bring these solutions together to create completely cohesive, new modern approaches to old problems.
Mm-hmm.
Yeah, I have a last thought there, Scott, is it is a big trend right now in the robotics industry that more companies are bringing subsystems and components that then another robot company can assemble together to create a robotic solution. And I'm excited about that because we're part of that direction. Some examples are Tanagram, Slamcore, Forma, Inorbit, Foxglove, and then the Move It Studio that I was showing earlier. And so it's to be seen how successful that is. It could be that we're too early to have a component-based platform, and maybe it needs to be more bespoke, all built in-house. Like in the olden days, a robot company had to build everything from the ground up, and it was very slow and very expensive. And my bet is that that's no longer the case, and that in order to move faster and solve these problems, we need to work together and have that ecosystem you alluded to.
All right. So my final question for all of you is, where is relevant? If you could share metrics around maybe as a percentage uptick or number uptick in terms of kind of qualified leads or sales conversions that you've seen in the recent years that reflect the truth on the ground, as well as any type of startup metrics that you'd like to share with those that are watching.
Yeah, so I'll go. So last year, we received 350 inbound leads for our solution. In the last 2 quarters, we've received over 1,800 from companies of all shapes and sizes. So if there's, I think it's indicative of the level of demand and the need for more robotics being deployed into our sector, manufacturing. And we deployed double the amount of robots last quarter than we had in any previous quarter in our company's history. And so those are 2 metrics that should kind of give a good sense of where the scale of this market is going and the level of demand and need for robotics in not just manufacturing, but really every sector.
I'll share that we're getting about 1 to 2 inbound leads a day currently, which is quite overwhelming for us to handle. But many of the robotics companies in the market, when I talk to the CEOs, I'm surprised that despite lots of funding, they have very little revenue, and we are pushing like 10 million in revenue this year. So like we're seeing a lot of demand for needs for advanced robotics for all sorts of other robot companies who come that we serve.
Great. And how about you, Wesley? What kind of metrics are you able to share at this point?
Yeah, so we are definitely not at the thousands of leads today yet. So the whole industry is growing about 30 to 40% per year over year, and the Inflation Reduction Act really give us a lot of tailwind. And we are working with a few big auto OEMs and battery manufacturer right now on designing a system to effectively recycle and reuse their batteries. And we are looking to get to a couple $1 million revenue end of next year, and that's kind of what we are targeting before our Series A.
All right, I'm going to pass it back to David Nichols.